Hello everyone, in this video we are going to learn exercise 1.4. In the previous videos I explained 1.1, 1.2 and 1.3. If you didn't watch those videos, the link is in the description, watch it. Okay, the first bit is prove that the following are irrational numbers. First question, 1 by root 2. We need to prove that 1 by root 2 is an irrational number. So we are going to solve these kind of problems by one method. It is called proof by contradiction. So let us check how to solve it. On the contrary, let us assume 1 by root 2 is rational. On the contrary, let us assume 1 by root 2 is rational. So, if 1 by root 2 is rational, it can be written in the form of a by b. Actually, we will represent rational as p by q form, but our textbook is following a by b form only. So that's why here also we are writing a by b only. On the contrary, let us assume, just we are assuming that 1 by root 2 is rational. So if it is rational, 1 by root 2 can be written as a by b form, where a comma b are integers and co-primes and b is not equal to 0. This condition is must and should. 1 by root 2 is equals to a by b, where a comma b both are integers as well as co-primes and the denominator b is not equals to 0. So now I have 1 by root 2 is equals to a by b. So what I will do completely, I will reciprocate the equation. Reciprocating the equation. So 1 by root 2 will become root 2 by 1. A by b will become b by a. Here root 2 divided by 1 is nothing but root 2, which is equals to b by a. Now if we observe clearly, here we took a, b both are integers. So whatever the number you want from the integers, if you substitute in the place of b as well as a, this total value will become a rational number only. Now this LHS root 2, already we know root 2 is an irrational number. Left side we have irrational and right side we have rational. Irrational number never be equals to rational number. So we got this contradiction. We got this contradiction due to our wrong assumption. Here we assumed wrong. That's why here we got this wrong contradiction. Due to our wrong assumption. So 1 by root 2 is an irrational number. Here a, b both are integers, so RHS is rational, whereas LHS is irrational. We got this contradiction due to our wrong assumption. So 1 by root 2 is an irrational number. Okay, let's move to second question. Show that root 3 plus root 5 is an irrational number. Here two terms are there and both the terms are irrational numbers only. Root 3 is an irrational, root 5 is an irrational. So first step as usual, on the contrary, let us assume root 3 plus root 5 is rational number. So if it is rational, then root 3 plus root 5 is equals to a by b, where a comma b belongs to integers as well as a comma b are co-primes and b is not equals to 0. Now what we will do, squaring on both the sides. Squaring on both the sides. So we get root 3 plus root 5 whole square is equals to a by b whole square. Now this root 3 plus root 5 whole square is in the form of a plus b whole square. So if we expand it, a square plus b square plus 2 into a into b is equals to a by b whole square can be written as a square by b square. Square root square cancel, square root square cancel. So this is 3 plus 5 plus 2 into root 3 into root 5 root 15 is equals to a square by b square. 3 plus 5 8 plus 2 root 15 is equals to a square by b square. 8 I will take to the left side. So we will get 2 root 15 is equals to a square by b square minus 8. 2 root 15 is equals to a square minus b square into 8b square divided by b square. Now I will take this 2 also to the right side. So root 15 is equals to a square minus 8b square divided by, here left side 2 is multiplication. So if we take another side, it will become division. 2 into b square. So root 15 is equals to a square minus 8b square divided by 2b square. Now if we observe clearly, a as well as b, we know very well those are integers. So whatever the value you substitute in the place of a and b, this total RHS will become rational number only. Whereas this root 15 is irrational number. We got this contradiction due to our wrong assumption. So root 3 plus root 5 is an irrational number. Okay, the next question is, show that 6 plus root 2 is an irrational number. In this case, 6 is one term and root 2 is one term. Two terms are there, whereas the first term is rational number and second term is irrational number. So first step as it is. On the contrary, let us assume 6 plus root 2 is rational. So 6 plus root 2 is equals to a by b, where a comma b are integers and co-primes and b not equals to 0. So now here one term is rational, one term is irrational, so no need of squaring. Directly take 6 to the right side. Root 2 is equals to a by b. This plus 6, if we take to the right side, it will become minus 6. So root 2 is equals to a minus b into 6, 6b whole divided by b. Now if we observe, a as well as b both are integers. So this total RHS will become a rational number. Whereas LHS root 2 is an irrational number. So irrational number won't be is equals to rational number. So we got this. We got this contradiction due to our wrong assumption. So 6 plus root 2 is an irrational number. Okay, next fourth question is root 5. Show that root 5 is an irrational number. I will come to this question after finishing the last question. Okay, the last question is show that 3 plus 2 root 5 is an irrational number. So here also same first line as it is. On the contrary, let us assume 3 plus 2 root 5 is rational. So 3 plus 2 root 5 is equals to a by b. Here 3 is a rational number, 2 root 5 is an irrational number. So one rational, one irrational. No need of squaring on both sides. Simply take this 3 to the right side. 2 root 5 is equals to a by b plus 3 will become minus 3. 2 root 5 is equals to a minus b into 3. 3b whole divided by b. Now same way I will take this 2 also to the right side. So root 5 is equals to a minus 3b divided by, here 2 is multiplication, if we take another side it become division, 2b. Now a comma b are integers. A, B both are integers, so whatever the number if you substitute in this place of a and b, this total RHS will become rational number. A and b are integers, so RHS is rational, whereas this LHS, that is root 5, is an irrational number. This contradiction has arisen. This contradiction has arisen due to our wrong assumption. So 3 plus 2 root 5 is an irrational number. Okay, now let us move to the fourth question. Show that root 5 is an irrational number. Till now we discussed the problems where the given question is in the form of 1 by root something, or root 2 plus root 3, or 2 plus root 3, or 2 plus 2 root 5 something. Now it is having only single term, so only root 5 is there. Now how to solve these kind of problems? The first step, as usual, on the contrary, let us assume root 5 is rational. So root 5 is equals to a by b, and here squaring is compulsory. Squaring on both the sides. Root 5 whole square is equals to a by b whole square. Here square root and square cancel, so we remains with 5 is equals to a by b whole square is a square by b square. Now I will take b square to the left side. So this b square is division. If we take another side, it will become multiplication. 5 into b square is equals to a square. This is equation 1. Now this 5 I will take to the right side. So b square is equals to a square by 5. Here a square by 5 means 5 divides a square. A square by 5, which is in the numerical form, I am writing in the statement form. A square by 5 means this 5 divides a square. So if 5 divides a square, 5 divides a also. If 5 divides a square, 5 divides a also. This 5 divides a can be written as a divided by 5 with some constant c, because phi is dividing a means compulsory some number will come, I mean that quotient will come, so that quotient I am representing with C. Now this phi I will take to the right side, so we get a is equals to phi into C. This is second equation. Now if we observe the first equation, phi b square is equals to a square. Second equation, a is equals to phi c. So here in the place of a, I will substitute this phi c. This a value I will substitute in the equation 1. Equation 2 I will substitute in equation 1. Okay, these are the two equations we have. Now this second equation I am substituting in the first equation. Phi b square is equals to, in the place of a, phi c whole square. So phi b square is equals to phi c whole square, 20 phi c square. Phi ones are, phi fives are. So b square is equals to phi c square. Now this phi I will take to the right side. So we get b square divided by phi is equals to c square. This b square by phi is in the numerical form. If you write this in statement form, phi divides b square. Phi divides b square. If phi divides b square, phi divides b also. Phi divides b also. In the previous step, we got phi divides a. And now we got phi divides b. So I can conclude phi divides a and b. This contradicts the fact that a comma b are co-primes. In the beginning of the step only, in every question, when we assumed that it is a rational number a by b, we said very clearly a and b both are integers as well as co-primes. A and b both are co-primes. So co-prime means a and b doesn't have any common factor except 1. But whereas in this case, phi is dividing a and b, so it means phi is also a common factor of a and b. So that's why it is contradicting the fact that a comma b are co-primes. So root phi is an irrational number. Okay, second bit is prove that root p plus root q is an irrational number where p comma q are prime numbers. So here p, q both are irrational, I mean root p, root q, two terms are irrational only. So squaring is compulsory in this. First step as usual. On the contrary, let us assume root p plus root q is rational. So root p plus root q is equals to a by b, where a comma b are integers and co-primes as well as b not equals to 0. So here two terms are irrational, so squaring on both the sides. Squaring on both the sides. So we get root p plus root q whole square is equals to a by b whole square. This is a plus b whole square formula. So if we expand, root p whole square plus root q whole square plus 2 into root p into root q is equals to a square by b square. Square root square cancel, square root square cancel. So we remains with p plus q plus 2 into root pq, which is equals to a square divided by b square. Now this p plus q I will take to another side. So we will get 2 times root pq is equals to a square by b square. This plus p will become minus p, plus q will become minus q. So 2 times root pq is equals to a square minus b square into pb square minus b square into qb square whole divided by b square. Now I will take this 2 also to the right side. Okay, left side we have 2, that also I am taking to the right side. So we get root pq is equals to a square minus pb square minus qb square divided by 2b square. And in the question he clearly mentioned that p and q both are prime numbers. P, Q are prime numbers according to the question. And already we know that a comma b both are integers, so it means these are prime numbers, are real numbers, integers also real numbers only. So a p b q, whatever the numbers you substitute in the place of this total RHS is a rational number only, whereas this root pq is an irrational number. This contradiction has arisen due to our wrong assumption. So root p plus root q is an irrational number. This contradiction has arisen due to our wrong assumption. So root p plus root q is an irrational number. Till now, if you didn't subscribe to my channel, subscribe for more videos. Thank you.